Explore your SQL journey. Welcome to our comprehensive SQL course that will take you from a beginner to a pro level. In this course, you will learn the fundamental concepts of SQL and gradually move towards advanced topics. Whether you are a beginner with no prior knowledge of SQL or an experienced programmer looking to enhance your skill, this course is designed to cater to your needs. With our well-structured curriculum, you will be able to progress through the beginner, intermediate, and advanced levels at your own pace. Through the course, you will have access to multiple quiz options, which will help you reinforce your understanding of the concepts covered in each level. Ready to embark on an exciting journey that will take your SQL skills to the next level. So let's get started. Welcome to the introduction to SQL and databases. Databases are a collection of organized data stored, managed, and accessed electronically. There are different types of databases, but in this topic, we'll be discussing the Relational Database Management System, which is known as RDMS. RDMS is a database that stores data in a structured way using tables and relationships. Example of RDMS includes MySQL, PostgreSQL, and Microsoft SQL Server. SQL, which is known as Structured Query Language, is a structured language used to interact with relational databases. SQL can create, update, and retrieve data in a database. There are three types of SQL commands. First, we have the data definition language, which includes create, alter, and drop. Create command is used to create a new table or database. Alter command is used to modify an existing table or database, and drop command is used to delete a table or a database. Secondly, we have the data manipulation language, which includes select, insert, update, and delete commands. Select is used to retrieve data from a table or database. Insert is used to insert new data into a table or database. Update is used to modify existing data in a table or database. And delete is used to delete data from a table or database. Lastly, we have the data control language, which includes grant and revoke. Grant is used to give access privileges to specific users, while revoke is used to remove access privileges from specific users. Summarize. RDMS is a type of database that uses tables and relationships to store data in a structured way, while SQL is a language used to interact with RDMS. The three types of SQL commands are DDL, DML, and DCL. Relational databases are a type of database that organizes data into tables with rows and columns. Relationships between tables can be established using keys. Here are some of the characteristics of relational databases. First, they support transaction and constraints. Transactions ensure that multiple operations are performed as a single unit of work, and constraints enforce rules to maintain data integrity. First, we have the data definition language, which includes create, alter, and drop. Thirdly, SQL is widely used and well established in the industry. SQL provides a standardized way to interact with relational databases. It allows for complex data relationships to be modeled and easily queried. It also enables efficient data management and analysis. On the other hand, NoSQL databases are a non-relational database that can handle large amounts of unstructured data. Examples of NoSQL databases includes MongoDB, Cassandra, and Redis. Lastly, flat file databases store data in a plain text file. Example of flat file databases include CSV, which is a comma separated values. To summarize, relational databases organize data into tables with rows and columns, and relationship between tables can be established using keys. They support transactions and constraints, are scalable, and can handle large amounts of data. SQL is widely used and well established in the industry. No SQL databases can handle large amounts of unstructured data, while flat file databases store data in plain text files. Thank you for listening to this topic. We hope you find it informative and useful. Stay tuned for our next topic. What is a database? What is the purpose of a database? There are the two main types of databases. What is a relational database? Is a NoSQL database. What is a flat file database? What is SQL? What are three main categories of SQL commands? What is the purpose of the data definition language in SQL? What is the purpose of the data manipulation language in SQL? Welcome to the topic of overview of SQL data types. In SQL, data types are used to specify the type of data that a column in a database can hold. This is important because it helps to ensure data integrity and consistency, as well as optimizing the performance of database operations. One of the categories of SQL data types is numeric data. These includes integers, big integers, small integers, decimal, numeric, float, and real. These data types are used to store numeric values such as whole numbers or decimals. Integers and big integers are used for whole numbers, while small integers is a smaller version of integers. Decimal and numeric are used for exact decimal values, while float and real are used for approximate decimal values. To demonstrate, let's say we have a table named numbers with columns ID, decimal value, and float value. We can create this table using the command written in the bottom of this slide. This command creates a table with an ID column of type integer, a decimal value column of type decimal with a precision of 5 and a scale of 2, and a float value column of type float. Character and string data types are used to store character strings, such as names or addresses. There are three main data types used for this: character, variable character, and text. Character is used to store fixed length strings, while variable character is used to store variable length strings. Text is used to store large amounts of text data. To illustrate, let's say we have a table named names with columns ID, first name, last name, and description. We can create this table using the SQL command number 1. So this command creates a table with an ID column of type integer, a first name column of type character with a length of 50, a last name column of type variable character with a length of 50, and a description column of type text. Date and time data types are used to store date and time values. There are four main data types used for this: date, date time, and timestamp. Date is used to store just the date. Time is used to store just the time. Date time is used to store both the date and time, while timestamp is used to store a date and time value with a time zone. To demonstrate, let's say we have a table named dates with column ID, date value, date time value, and time value. We can create this table using the SQL command number 2. This command creates a table with an ID column of type integer and columns for each of the four date/time data types. In this section, we will cover how to create tables in SQL, which involves specifying columns and their data types, as well as any constraints that should be applied to the data. The different parts of the syntax are: create table, the SQL statement used to create a new table, table name, the name of the table being created, column 1, column 2, the name of the columns in the table, data type 1 and data type 2, the data types of the columns in the table, constraint 1, constraint 2, any constraints that should be applied to the data stored in the table, such as not null and primary key. Now we will learn about inserting data into tables. There are different parts of the syntax. When you see this SQL code, there is the first thing, which is insert into, which takes the SQL statement used to insert data into a table. Then we identify the table name. Then we identify the columns, column 1, column 2, and next we define the values. So it is again the same value that you need to enter into column 1 and column 2. So at a nutshell, you need to, like, how practice makes a man perfect. So the more you are going to practice these things moving forward, you will learn gradually and you will learn how to make use of these things. In the following example, first, using this SQL code, the first thing is that you need to create a table named users, which is like it has columns ID, which is an integer, and it is like going to be the primary key. Then we have got name, which is again a variable character with 50 characters. Email, again variable characters with 100 characters in that. And then in the second line, we're gonna use the insert into command. So insert into table name users, and then we have got column names ID, name, email, and then we are going to define the values, which is one John Doe and John Doe at example.com. Now, in this section, we are going to talk about the basic select statements and its syntax. So, in you say, a select statement is used to query data from a database and retrieve the desired information. And obviously, it is the most commonly used SQL statement, and you can say it's a backbone of most SQL-based applications. So, going through these codes, the basic SQL select statements. We'll start with the simpler version, and it can be like turned into a very complex thing. So you need to understand the basics, and when you understand the basics, then you can like create like very complex logics into this. And but the concept has to be clear. So using this SQL code, so what we have is like column one, column two from the table name, which is this is the simplest. Then we have got like the different parts of the syntax that he needs to understand. It's the first thing is the select. Then we are going to identify the columns. From is again from where the table name. So you can have a like a SQL code like select star from users. It will give you everything about the table name users, or you can identify the columns like select name email from users. So these are the two example. Again, a very simpler version of what we are gonna learn over time, and we're gonna practice. But again, the concept has to be clear. Once the concept is clear, you can start from the very basic and develop your logics into a very like a complex manner and use those complex logics into these statements. Okay, so now in this last section of data types and basic SQL statements, we're going to learn about additional features of SQL statements, which are you can filtering data. So you use the where clause to filter data based on specific conditions, or if you need to sort data. Sorting data is again, you are going to use the command order by clause to sort data in ascending or descending order based on like one or more columns. Similarly, you can group data. So grouping data is again, you need to use the group by clause to group data based on specific columns. You can also use like the limiting the number of rows returned to use the limit clause to limit the number of rows returned in a query. So following are some codes which you can do some practice. So like in the first code, select ID, name, email from users where ID is equal to 1. So now only the result of ID1 is going to be displayed. On the second SQL code, select name, email from users, order by name descending. So descending is used again to like show the results accordingly. You can choose ascending or descending accordingly. Now again, after that we have select name count star from users group by. Now since we had to do the count star, we have used the command group by to do that. In the last SQL code, we are going to use select star from users, and we're going to limit the rows to 5. So this is going to show just the 5 rows. Which SQL command is used to create a new table in a database? What is the syntax for creating a new table in SQL with two columns, ID and name? What is the SQL statement used to insert data into a table in a database? What is the syntax for inserting data into a table in SQL with two columns, ID and name? What is the SQL statement used to retrieve data from a database? What is the syntax for retrieving all columns from a table in SQL called users? What is the syntax for filtering data in a select statement based on the value of the ID column being equal to 1? What is the syntax for sorting data in a select statement in ascending order based on the value of the name column? What is the name of the constraint that ensures a column cannot contain a null value? What is the keyword used to specify the name of the table from which data is being retrieved in a select statement? What is the syntax used to retrieve all columns from a table in a select statement? What is the syntax used to filter data based on specific conditions in a select statement? What is the syntax used to group data based on specific columns in a select statement? What is the syntax used to limit the number of rows returned in a select statement? We are going to start the advanced select statements. In this section, we're going to talk about using where clause for data filtering. The where clause again it can be used to filter data from a table based on specific conditions. The conditions we're going to discuss further. It can be used in the select, update, and delete statements. So the syntax is very simple. Like you can select column name from table name where and apply the where condition, and the conditions can be any expression that evaluates true, false, and and it can use comparison operators or logical operators also, like and or not. So when you look at the code, like select star from table name employees where salary is greater than 50,000. So this statement is going to return all the columns from the employee table where the salary is greater than 50,000. So you can use any comparison operators or logical operators to get the answer as per your logic, and you can apply these logic in multiple ways. As Now we are going to talk about the joins. So how can we join multiple tables? So a join operation is used to combine rows from two or more tables based on a related column between them. So there are like several types of joins, including inner join, left join, right join, and full outer join. Inner join mainly returns only the rows matching values in both the tables, where left join returns all rows from the left table and matching rows from the right table. If there is no match, null values are returned. Similarly, right join returns all rows from the right table and matching rows from the left table. If there is no match, again null values will be generated. Full outer join returns all rows from both tables and matches where available. If there is no match, null values are generated. So if you follow these codes, again select column name from table name, you're going to use join table 2 on table 1. So we're going to define the column name which is equal to table 2. Table 1 column name is equal to table 2 column name. In the second thing, like you can say select employee name, department name from employees table, left join departments on employee department ID, which is the column name equals to department dot department ID. This statement would return the name of each employee and the name of their department, joining the data from the employees and department tables on the department ID column. Grouping and aggregating data with group by and aggregate functions. The group by clause is used to group rows that have the same value in specified columns. Aggregate functions can be sum, average, count, and are used to perform calculations on the group data. So when you look at the syntax, the SQL code they're going to use is select column name, aggregate function, column name within brackets from table name, group by, column name. So when you look at this SQL code, select department name, we're going to use the aggregate function as average salary. We need to see the average salary from employees, and we're going to group by the column department name. So this statement will return the average salary for each department calculated by the grouping the data in employee tables by department name column. In this section, we're going to talk about subqueries and derived tables. A subquery is a select statement nested within another statement. A derived table is a table created within the from clause of a select statement. Subqueries and derived tables are used to retrieve data from one table based on data from another table. So this is again the basic where now we are gonna move towards from the basic select statements to advanced select statements, where we are gonna build a bit more complex logics. So subqueries can be used in several places in SQL statements, including the select, from, and where clauses. Syntax for a subquery in the select clause can be select column name, select where, like within brackets, select column name from table name where condition is applied, and as derived table name from the table name. So when you look at these codes, we can say as use the SQL code as select name, select maximum salary from employees as maximum salary from employees. So this would return the name of each employee and the maximum salary in the employee table using a subquery to calculate the maximum salary. Again, the SQL code can be the select name, department name, salary from select within brackets. Now we're going to use the subquery in this, like select name and department ID salary from employees as employee data. Left join, we're going to use joins in this. Left join departments on employee data. Department ID is equal to department ID. Departments dot department ID. This statement would return the name, department name, and salary for each employee using a derived table to simplify the query. So see, that's what I'm was like trying to tell you. Like now we are gonna build a bit more complex logics, and we're gonna learn over time how to become an expert in these like building the logics. In this section, we are going to talk about pivoting and unpivoting data. Pivoting again is a process of transforming rows into columns, and unpivoting is the opposite of pivoting, transforming. So these operations are used to change the structure of the data for better analysis and reporting. Uh, you can look at the code, and this statement would return a table with one row for each year and one column for each product showing the sum of sales for each product in each year. So, similarly, the SQL code for unpivoting data, if you use this statement, would return a table with one row for each column and product combination showing the sales for each product in a year. Now, you need to understand the logic why we pivot or unpivot the data. Pivot is again when you have a long table and you need to summarize the data. Now, this again can be a very basic pivot, or it can be a very complex pivot also. So you need to understand your like the logic that you're gonna build on how do you want to summarize the table and use the data accordingly. Or if you want to use the unpivoting option for a summarized data and create like converting it back to the table form. What is the purpose of the where clause in a select statement? What is the result of the following select statement? What is the purpose of a derived table in a select statement? What is the result of the following select statement? What is the purpose of pivoting data? The purpose of the group by clause in a select statement. The purpose of a join in a select statement. What is the purpose of aggregate functions in a select statement? For example, sum, average, count. What is the purpose of a subquery in a select statement? What is the purpose of unpivoting data in a select statement? In this section, we are going to talk about the data modification. So data modification, which is a crucial aspect of database management, and it enables organization to keep their data up to date and accurate by using insert statements, update statements, and delete statements. Firstly, let's talk about insert statements. So we use the command insert into, and the SQL code for inserting text data can be insert into, so table name, column names, and then you're going to define values. So there are multiple variations where you can do that, and these things are like self-explanatory, and you should practice to understand them better. But there are multiple options. There is no end to these things. Next in the line is updating data in the tables. So to update any data in a table, we need to use the update command. So we use the update statement, which is like followed by the name of the table, and you use the set clause, which specifies the new value for the columns, and we used to use the where clause also. So it specifies which row or rows should be updated. So the basic like syntax is like update table name, set column 1 value 1, column 2 value 2, where some column is equal to some value. So you can use these things. Similarly, for deleting data in tables, the delete statement is used to remove data from a database. To delete data from a table, delete statement is used. The statement is followed by the name, which is like of the name of the table, and a where clause is used, which specifies the row or rows should be deleted. So the code for deleting data can be like delete from customers, where customer ID is equal to 1. In this section, we are going to talk about data modification and overview of transaction and their importance. So to have a clear understanding, a transaction is a sequence of one or more database operations that are executed as a single unit of work. Transactions also ensure that the database remains in a consistent state even in case of failure or errors. And they also they help to ensure the data integrity by making sure that all operations within a transaction are completed, or if any operation even fails, all previous operations are rolled back. Then advanced data modification techniques using SQL, which are like it can be batch processing, the execution of multiple operation as a single transaction. It can be a prepared statement, which are the reusable pre-compiled SQL statements, which help to improve the performance of database operations, or it can be a stored procedure. Stored procedure is again a set of SQL statements stored in the database and executed as a single unit. Or we can use triggers. Triggers again are automated procedures that are executed in response to certain events such as inserting, updating, or deleting data. So an SQL code for a create trigger is written as where it is again depending on the lead and depending on the logic, it can be from a very simple version to a very complex one. These things all help in like modification of data and maintaining these things in a proper manner and building your logics from a simpler one to a very complex one. What is data modification? Which statement is used to insert data into a table? What clause is used to specify which row or rows should be updated? What statement is used to delete data from a table? What is a transaction in database management? Do transactions help ensure in a database? What is a stored procedure in SQL? What is a trigger in SQL? What is a batch processing in SQL? What is a prepared statement in SQL? Management is the process of collecting, storing, organizing, maintaining, and using data effectively to meet your business needs. The key concept which needs to be cleared is on data modeling and normalization, data design and administration, storage and retrieval, data security and privacy. The best practices that one should adopt is taking regular data backups and disaster recovery planning, data security and privacy policies, data governance and ownership, regular data maintenance and updates. Let's talk about creating and altering tables. So first you need to understand and develop your concept about relational databases. A database model where data is organized into tables with relationships between them. So when you need to create a table, you need to use the SQL syntax as create table statement, where you just specify columns, data types, and constraints. Adding, modifying, deleting columns in a table can be done through an alter table statement. You can use add columns, modify columns, or drop column. So these are the clauses that can be used, or altering table constraints and relationship, where you can add constraint or drop constraint clause can be used in specifying foreign keys and referential integrity constraints. In this section, we're going to talk about SQL codes to create a table for books. So this is how the syntax is written, where you can create a table for the table name books and identify all the columns and its constraints, and followed by it's like adding, modifying, and deleting columns in the table. How do you alter table? By adding column or modifying column or altering table constraints and relationship, by altering table, adding constraints, or dropping constraints. In this section, we're going to talk about indexing and optimizing database performance. So indexing is like, again, a database optimization technique that provides like quick access to database on specific search criteria. So it improves database query performance. It also reduces database response time. So the types of indexes that can be used are primary index, foreign key index, secondary index. Index design and maintenance, again, is like when you choose the appropriate index type, index tuning and maintenance. The common performance optimization techniques includes query optimization, proper indexing, effective data storage, regular database maintenance, and updates. As the data grows, these things are very important to use, and it helps you run the queries effectively. So there are multiple skill codes are followed in the slide, where you can have an idea on how to do the indexing using these codes, and how to maintain and how to monitor index usage. In this section, we are going to talk about importing and exporting data from and to external sources. See, again, import and export process is transferring data between databases or between a database and a file. So you can import from a CSV file, Excel spreadsheet file, XML, JSON file, which is a JavaScript object notation, or like importing and exporting data from and to databases. Again, from one database to the other, importing and exporting both can be done using the SQL statements or database tools. In this section, we're going to talk about SQL codes, on how to write the codes for importing data, exporting data, and transferring data between databases. So these are the different codes which you can use for bulk insert, or exporting data, or to a CSV file, or transferring data between one database to another. As your databases grow, so you need to use the advanced database management and monitoring techniques, where you need to understand advanced data management by data replication, load balancing, database partitioning, or managing the security and backups, on how to do the user authentication and authorization, encryption and decryption of data, regular backup and disaster recovery planning, database monitoring and performance tuning. So how do you do the database performance? How do you do the utilization and the utilizing database tool for management and monitoring? So these are multiple things which over the time you get to use them as your data grows. In this section, we talk about how do you make create the backup and recovery strategies, database security, monitoring database performance. Again, these are very lengthy topics and very short examples are given just to clear your concepts. So this is a concept driven exercise where we are trying to build your concepts about advanced data management techniques, because again these itself data management techniques can have long presentations, more than an hour presentation on learning data management. So we'll cover that separately, but this is again to clear your concepts. Can you create an index in a database? How can you rebuild an index in a database? What is the SQL statement to import data from a CSV file into a table in a database? What is the SQL statement to export data from a table in a database to a CSV file? What is the process of regularly checking the performance and health of a database called? What is the purpose of indexing in a database? What is the process of copying data from a source database to a target database called? What is the process of storing multiple copies of data in different locations called? What is the process of restoring data from a backup to a database called? Now we come to the section of advanced SQL concepts. I love this, like the advanced side of where you can really build logics, you can build your complex questions into logics and get those answers in multiple ways. Uh, the one thing is like your concept should be very clear in what question you need to address, and accordingly you can build a complex or a simpler query. So there are many ways of doing it, and we'll talk about that. So I would like to talk about subqueries. Subquery is again a query which is nested within another query, and that retrieves data to be used in the main query. So the syntax for these writing these subqueries can vary, like depending on your business needs and the data management system being used. There are several type of subqueries, including firstly we'll talk about scalar subqueries. So in a scalar subquery, it returns a single value as a result of the query, and the subquery must represent exactly one row and one column to be considered. And the return value can be expression, comparison, or anywhere a single value is required. Within subqueries, the second thing is row subquery. So a row subquery is again a subquery that returns more than one value as a row in this result set. So the subquery may return one or more rows or one or more columns to be considered as a row subquery. The return results can be used in a comparison operator such as not in, exist, or not exist. So these are like you can say much in use and greatly like depends on how you want to build in your logics. Then we have correlated subqueries. Correlated subqueries again is a subquery that uses values from the outer queries to execute the inner query. So inner query is executed multiple times, once for each row of the outer query, and the result of the inner query is used in the outer query. Subqueries are like again used to solve complex problems and can significantly reduce the amount of data that needs to be processed. We'll talk about further in detail in the following slides. These are multiple SQL code syntax which can be used for scalar query, row subquery, or correlated subqueries. So like all the syntaxes are written in a different manner, and the objectives are different. So objective can be if you need a single row, multiple rows, or result from an outer query. So based on that, you can use these codes. And again, I would suggest that you should practice them well on your data sets. And because see, the best thing that one can learn is from your own data set, and that is the best way to practice it. Exploring the advanced SQL concepts further, the second thing in line is joins. Joins, as mentioned earlier also, is a method of combining data from two or more tables based on a related column between them. So the syntax, it can be again a very simplified and can be created in a very complex manner. So it really depends on the database management system being used. But there are several types of joins, including like you can say inner join, left join, right join, full outer join. Depending on the need, you use these joins accordingly. So joins are used to combine data from multiple tables to produce a single more or complete result. So, as an example, the inner join SQL syntax can be select column one, column two from table one, where you can join table two on table one dot column is equal to table two dot column. Again, like these things are more like as you go further, as you practice, you get to know how to join them, how to join several tables at the same time to get the desired results. Because this is the main key where you model the things and you join and you get to the derived results, that the desired result that you want to get. Here you can see the different SQL code syntax for left join, where you need the data from the left table, or the right join where you need the data from the right to be main dominating, or the full auto join where you need the data from both the tables. So depending on the need, you need to dig deep dive and understand what kind of data, what are the uses, and how you can deal with them. Again, depending on case to case basis, these things differ, and you need to understand where to use these joins, how to use these joins, and to practice. If you want to learn much deeper into these sides, joins, you can leave comments and we can build very detailed presentations just on our videos, just to make you understand how to make SQL code syntax for joins in detail. In this section, you will learn that there are some window functions which can be used in a select statement to do some aggregate calculations, which can be very complex aggregate calculations also. Like for example, you can use several types of window functions, including row numbers, rank, dense rank, and tile. So depending on the need, it really varies from one business need to the other, or one case to the other. What exactly do you want to achieve through the data? So depending on that need, you can use the appropriate window function to get your result accordingly. In this section, you can see how to use these Windows function into select statements, how to write the SQL code for row number, rank, dense rank, or n tiles. Stored procedures are precompiled set of SQL statements that can be executed repeatedly with different inputs. They are used to perform complex business logic. So if you've got a business logic which you want to use repeatedly, so you can create a stored procedure for that, and it can be efficient to use more than executing it multiple times in separate SQL statements. So you create one procedure and it can be used with multiple SQL statements when you call that procedure. Triggers are special types of stored procedures that automatically executes in response to special, like you can say any event such as insert, update, or delete operation on a table. So they can be used to enforce business rules, maintain data integrity, and automated repetitive tasks. Again, it's a database object that is automatically executed in response to a set event, such as insertions, updates, or deletions on a specific table. Triggers are used to enforce business rules, perform calculations, or maintain data integrity. But they are very critical in terms of if you want to execute any command based on a derived result. So these are very useful in terms of that. Its codes are written here and it can be practiced, and it can be used for very complex logics based on any business rule which can be done. An index is a database object which provides a fast, efficient way to retrieve data from a table based on values in one or more columns. By creating this index on a column or a group of columns, you can really speed up your queries that filter, sort, or aggregate data based on the values. The codes are written here, but the thing is what you need to understand is that the more you have that as your data grows, indexes are very useful in making efficient queries and driving results in a very fast manner. A materialized view is a pre-computed cached result set that is stored in the database and can be used to improve query performance. Views in your normal use are very useful, as it creates a view of a database object that is created based on a select statement and can be used in place of the original select statement for improved performance. So in case you summarize a certain amount of data and you use that frequently, so you can create a view for that, and instead of writing that SQL statement, that view gets updated and you can use that view in your query, and it can be very useful. So based on, again, how complex and how logical you are in your thinking, and how complex do you want to create these views, they are very useful in normal routine of database usage and writing SQL statements. Partitioning is a database design technique which is used to improve your query performance and manage large amounts of data. So this is the key. Like if you have got large amounts of data, so you can do this partitioning by dividing it into smaller, more manageable chunks called partitions. So if your data size is increasing, or you already have a large data set, so you can do the partitioning so that the queries can be run efficiently and managed across different, like you can create different time period. It's a subquery in SQL. The purpose of using a join in SQL. The purpose of a stored procedure in SQL. What is the purpose of a trigger in SQL? It is an index in SQL. It is a materialized view in SQL. It is a query optimization in SQL. It is partitioning in SQL. With this, we come to the end of your SQL journey from a beginner to a pro level. In this course, you have covered the basic SQL fundamentals, and going from there to the using advanced techniques on how to manage. The idea of this course was to clear your concepts and build a complete journey to understand how SQL can be used in your daily task, in developing your business logics, and moving forward using these, managing the databases and managing advanced techniques. If you have liked the content of this course, do subscribe to our channel. We would definitely like to hear from you. So do uh, give us your comments if you would like to have further detail, because see, in this journey and having these concept, uh, like deep dive into these concepts, we can build separate more videos for you so that your journey of increasing your knowledge can go on. Thank you very much for going through this SQL journey from beginner to pro. With this, we come to the end of your SQL journey from a beginner to a pro level. In this course, you have covered the basic SQL fundamentals and going from there to the using advanced techniques on how to manage. The idea of this course was to clear your concepts and build a complete journey to understand how SQL can be used in your daily task, in developing your business logics, and moving forward using these, managing the databases and managing advanced techniques. If you have liked the content of this course, do subscribe to our channel. We would definitely like to hear from you. So do uh, give us your comments if you would like to have further detail, because see, in this journey and having these concept, uh, like deep dive into these concepts, we can build separate more videos for you so that your journey of increasing your knowledge can go on. Thank you very much for going through this SQL journey from beginner to pro.